Hey everyone, welcome to the Global NLP Lab, a place where we discuss the latest in natural language processing. In today's video, we will take a look at a recent paper that investigates the use of GPT-3 for data annotation, which is an exciting area where large language models can make a big impact. So, let's get started. Data annotation is the process of labeling data that can be used to train machine learning models and is a crucial step in the development of NLP systems. Data annotation can be a costly endeavor, particularly for university research groups or small and medium-sized enterprises. The cost of data annotation typically includes the labor costs associated with the labeling process, as well as the time and resources required to hire, train, and manage annotators. Given the impressive language capabilities of GPT-3, it is natural to wonder whether it can be used effectively to annotate data for NLP tasks, which leads to the current paper. The authors conducted experiments on two tasks: sentence classification and name entity recognition. They explored two approaches for generating training data for these tasks. 1. Data annotation, where existing unlabeled data is labeled with GPT-3, see top left of the figure, and 2. Data generation, where data is generated along with labels, top right. Both data annotation and generation are achieved through constructing suitable prompts for the tasks, along with providing examples for in-context learning. The authors fine-tune BERT models on the newly created synthetic datasets and compare the accuracy with models trained on human-labeled datasets of comparable sizes. The results of this paper are a bit mixed, but keep in mind that this is an early preprint. However, there are some interesting insights that can be drawn from the paper. On sentence classification, using the SSD2 dataset, data annotation was more successful than data generation. Data annotation, in fact, scored only 0.72 points worse than a human-labeled dataset of the same size, 3,000 data points. Annotating 3,000 additional data points with GPT-3 to get to 6,000 in total led to superior performance than the model trained using 3,000 human-labeled examples. On the entity recognition task, using the cross-NER dataset, the results are less impressive, with the GPT-3 labeler occasionally missing the boundaries of entities and sometimes incorrectly identifying entities. The data generation approach achieves better performance on this task than data labeling. The results of the paper demonstrate the potential of data labeling. Large synthetic datasets created by large language models can potentially be used to train and fine-tune much smaller models for a wide range of tasks. The synthetic datasets can be used on top of existing human-labeled datasets, or potentially on their own in certain cases. So to sum it up, the paper provides some insights into how LLMs such as GPT-3 could serve as general-purpose data annotators in NLP. The analysis is limited to simple tasks such as classification and entity recognition. It would be exciting to see the same approach applied to more complex tasks involving text generation. Furthermore, it would be interesting to experiment with annotating substantially larger datasets, as well as experiment with hybrid approaches that involve humans in the loop to ensure the quality of the data. This field is certainly bound to get very exciting over the coming years. So that's it for this video. Please like and subscribe to stay tuned to new NLP videos. See you next time.